Find an equation of a rational function f that satisfies the given conditions. We have a vertical asymptote at 4, at x equal 4, a horizontal asymptote at y equal -1, and an x-intercept of 3, 0. Let me pop up a graph that shows those characteristics visually. Okay, and there we see those characteristics graphed. To find the equation of a rational function with those characteristics, we know that a rational function is simply a ratio of polynomials. We're going to present those polynomials in factored form because it's easier to write down that way. A vertical asymptote of x equal 4 will be indicated by a denominator that is equal to 0 when x is 4. So x minus 4 is a factor that must appear in the denominator to give us this vertical asymptote. A vertical asymptote occurs if the 0 is in the denominator but not also in the numerator. If it had also been in the numerator, that would produce a hole, a single hole in the graph, but not an entire vertical asymptote. The next place to look is probably the x-intercept. That's at 3, 0, and that means that x minus 3 is a factor in the numerator. I say that because then when x is 3, we have 3 minus 3 is 0, and that produces y equals 0. So 3, 0 is a point now on this function. So far we've checked off those two conditions. Let's check the horizontal asymptote at y equal -1. To see that, we would need to take the ratio of the highest powers of x that are in the numerator and denominator. In that case, that's x to the first over x to the first, and the coefficients are both 1 in this case. And 1 divided by 1 is +1, not -1. So to correct for that sign error, we need to adjust our function that we're building and put a negative sign in either the numerator or denominator. Multiplying this out, we would have then 3 minus x over x minus 4, and now the ratio of the x to the first power terms is -1 divided by 1, which is -1, and that gives us the proper the proper horizontal asymptote. So this is the graph, the expression for the function whose conditions are listed here.